Hello, my name is Priya Subramanain and I'm a student doctorate of physical therapy at Regis University. Today I will be presenting using hand grip dynamometers to demonstrate active and passive insufficiency of wrist flexors and extensors. By doing maximum grip tests in multiple positions, we can begin to understand how lengthening and shortening the muscles affects the amount of force muscles can produce. By using EMG, we are able to understand the differences in muscle recruitment between flexors and extensors and active and passive insufficiency. We can understand this because excessive or insufficient overlap of thick and thin muscle filaments in maximum flexion and extension leads to suboptimal tension. This happens in passive insufficiency, or the lengthening of a muscle to its longest possible length, and active insufficiency, or shortening a muscle to its shortest possible length. In this research, we sought to answer how changing muscle length affected maximal muscle force and muscle recruitment. We hypothesized if we maximally shortened and lengthened the wrist muscles and hand grip lengths, the maximum force of contraction and muscle recruitment will be significantly less than in neutral position. For this experiment, we recruited 8 subjects, 50% male, 50% female, from Regis's 2021 DPT program. Average age was 26.5, ages 22 to 35. For the experiment, we found the muscle bellies of primary wrist flexors, extensors, and a nearby muscle group not involved in wrist contraction. We shaved those 3 areas and cleaned with alcohol wipes and then placed 2 EMG electrodes on each group, equaling 6 electrodes total. We adjusted the dynamometer, performed maximum grip tests in standard position, noting the force in kilograms and peak voltage in flexors and extensors, and then repeated this experiment on the shortest and longest setting of hand grip and wrist in maximum extension and flexion. When reviewing results, we can see that maximum force of contraction was measured to be the greatest in standard position and the smallest in maximum flexion position. However, the impact of shortening and lengthening the hand grip on force production was roughly the same. For the EMG portion of the study, in most positions, extensors had a higher EMG voltage than flexors. Additionally, EMG voltage decreased moderately in non-standard positions. If we use a confidence interval of 95%, generally no mean force or EMG voltage values are statistically significant. One exception to this is peak force in wrist position, which decreased significantly. Though these differences are not statistically significant, the data does show a distinct decrease in force and EMG voltage. To further study this concept, we should repeat the same experiment with a higher sample number. Overall, we can attribute the reduction in EMG voltage and force production to passive and active insufficiency, showing the impact of joint positions and strength. In the clinic, we can use these concepts when positioning a patient to prevent muscle insufficiency while strengthening and stretching 2 joint muscles. Furthermore, in designing exercise protocols and therapeutic interventions, we must keep these concepts in mind to optimize effectiveness of the exercise and safety. For example, using a tenodesis grasp and release for rehabilitating fine motor control. This has been a review of hand grip dynamometers to demonstrate active and passive insufficiency of wrist flexors and extensors. Thank you.